Hello, good day, ladies and gentlemen. Welcome back to my channel once again. So we love our very first chemistry class today, and the topic is electronic configuration in SPDF. But before I start with this, I would like to say few things about chemistry. You see, when you don't have the foundation or you don't have the right hand to put it in chemistry, it's going to be very, very difficult for you. You understand? But believe me, chemistry is one of the simplest science subjects. But you don't have a right hand to put it to is a problem, to be honest with you. And I mostly blame teachers, chemistry teachers. Their topics, see, it's not matter of maybe you recite 420 element. That is not chemistry. It's part of it. But you see this particular topic that I'm taking today as my first topic in chemistry. It connects so many things, so many topics in chemistry. It connects so many things there. So it's not just to come to class and learn first element and they will be singing with it. No, that's not what they call chemistry. We have some students that know first element even more than that, but they cannot write a simple ordinary chemical reaction to get the product. Please, that's why this channel, I dedicated this channel to help students, science students across the globe. So if you feel like you want to learn, and it's not matter of maybe you are seeing a particular channel having subscribers at maybe 5 and you see one that are having something like 20k subscribers, that doesn't mean that you are going to learn something from that one. So sometimes you just have to stick to what you want. Do you understand what I'm saying? But it's fine. So if you'd like to join our community, kindly hit the subscribe button now to stay updated on this channel. All right, now let's go back to our topic. Electronic configuration is just the arrangement of electrons in shells or energy levels, of which the energy levels are subdivided into what we refer to as the subshells. And the subshells, they are four. SPDF. Let me write it out. The subshells, they are just SPDF with the energy levels of 1, 2, 3, and 4. And this is N. Now, mind you, we don't call this N, we don't call this serial number here. We call it quantum numbers, because this particular study or electrical configuration in SPDF is based on quantum mechanics theory, or you can call it a models. Okay, so this N is called quantum numbers, not serial numbers. Please note that, or you call it energy levels. Okay, this is S, P, D, and F. Now I mentioned some certain things, but let me quickly brief that on with you guys. We have what we call shells. We have subshells, we have orbitals, and we have what we call the electron. These are things that guide, that connect this particular topic. In a simple word, what is a shell? Shell is just a building. Shell, just put it like this. Shell is just a building. It's just a building. All right, I will explain that in form of chemistry, but just listen to what I'm doing now. Shells, they are just building. Why subshells? They are just, let's say, floors in a building. The floors in a building. Floors in a building. Why orbitals? Let's call that a room in a floor. All right. Electron, we can say the number of people in the room. It's as simple as that. So if you can get this concept with this, I think you are good to go. Now, shell is a building. This is the building. Follow me. Look at it. This is the building. Do you understand what I'm saying? This is the building. Subshells, how many subshells do we have here? 1, 2, 3. That means SPD. That's what they call subshell. The floors. The floors, how many floors do we have here? We have 3 floors. SPD. Orbitals, they are room. That is, they are room in a floor. How many rooms do we have here? We have 2. Do you understand? We have 2. 2 rooms there. And here, how many do we have here? We can have, look at it. Look at that. Look at that. Do you understand what I'm saying? That's what they call the room. Why the electron is the number of people? Of course, number of people here, they are just 2. But remind you of something, please. According to Pauli's exclusion principle, the number of electrons you can have per room is 2. And the 2 must be opposite each other. That means, look at this. This is according to Pauli's exclusion principle under the same theory. So this is just the explanation to shells, subshells, orbitals, and electrons. So with that concept now, we can get the number of orbitals for SPD, number of orbitals. All right. So like I said, the number of orbitals for S is just simply 1, Pauli exclusion principle. Number of orbitals for P is 3. This is what? 5, and this is what? 7. So what do you observe? They are arranged in odd numbers. Okay. Number of orbitals for S is 1, P is 3, D is 5, and F is 7. This is according to Pauli's exclusion principle. And we can also find the numbers of electrons with the numbers of, since we know the number of orbitals. Mind you, I said something. I said that number of electrons, that's maximum number of people can live in the room per, they are just 2. So with that concept now, we can get the numbers of electrons. Numbers of electrons. So the number of electrons is just multiply all these ones by 2, and by 2. So this will give us 2, 6, 10, 14. It's as simple as that. So the number of electrons we have in S is 2, P 6, D 10, and F is 14. Number of orbitals we have here, they are 1, 3, 5. This 2 is not among them. Please. I only use that to get this one because the numbers of electrons per room is what? 2. That's why I have to multiply each of this one by 2 to get the result here. So this is how to this is the introduction to this particular topic. So in the next class, we are going to be learning how to write electronic configuration of every element. I'll see you guys in the next class. Bye for now.